Hello, everyone, and welcome. We are super excited for this next workshop that we have, our very first technical workshop of API Week. And we have Jeff Smith, who is joining us from the team at Oracle. I'm super excited for the content that he has prepared for y'all. So without further ado, I'm going to turn it over to Jeff to tell you about what REST APIs are and why you should care about them. I will let you take it away here.
Hey, thanks, Mary. Welcome, everyone. This part of the workshop, there's no homework. I'm going to be more of like in classroom mode, although I totally accept if you want to throw spitballs at me or throw paper airplanes, but let's make this as interactive and as fun as possible. We do have a lab that you can get your hands on that goes into working with REST APIs against some data that you have in a database. My name is Jeff Smith. I am a product manager here at Oracle, and we're probably most famous for, we own Java, we have a cloud, but we've been doing databases for almost as old as I am. But what I want to talk to you about today are a very particular type of API, REST APIs. And I need to get off the screen as quick as possible because you can see just how old my profile picture is because I've lost hair and my face is for some reason fatter. So let's get rid of that. All right, so it's API week. This is one of my favorite topics. APIs connect things, specifically programs. They can bridge two things together. It's a great way to pass data or to get work done. And the great thing about APIs as a developer, or if you're looking to get into development, is there's like this cookbook of like things you can order, you can just ask for. You don't have to do the work. There's just this service or server out there that's ready to give you stuff, and all you have to do is ask for it. It's amazing. And the RESTful or the REST APIs, they make things like the internet possible, like literally. So the team, the researchers at CERN that put together the research paper, the white papers that described how these interconnected things could work together. Like, you know, it's that technology that literally made the internet today possible. In fact, like a majority, like people say statistics are made up, and this statistic feels made up to me a little bit. So, because I'm like, how's that not 100%? But like a majority, or if nearly not everything that happens on the World Wide Web today is API driven. Like we couldn't do the favorite things we like to do today without APIs. So for example, I was busy today. I didn't have time to get my food. So I'll go into Grubhub or Uber Eats, whatever, and order that right off my phone. You know, my phone isn't making a hardwired connection to some computer somewhere. It's just making requests over my data connection, over my home Wi-Fi to some server in some cloud in Reston, Virginia, probably. That's connecting the menuing system, the delivery people, the payment providers, and all of that. And a lot of that code is just stitched together from existing APIs. Like developers aren't writing all of this stuff from scratch. You know, that they oftentimes can just concentrate on making the screen pretty, making the UX right, and then they just connect everything via APIs. Another example, banking, anything you're going to do in any sort of like online portal, it's like 100% REST API driven. And I'll show you in a little bit how you can see behind the covers, like literally what's happening when you point and click on things in your browser. Wearables, you know, these wouldn't work without APIs. This month, a bunch of us at Oracle have joined in on this crazy fundraising thing. If you remember the cold water bucket challenge, you thought that was dumb. You know, that's great because that just happens once. I'm doing this thing 100 push-ups a day, every day for the month of April. And I'm 5 days in, and my Garmin watch is screaming at me every morning to stop because I'm going to die if I don't. But I just ignore it, and I keep going, and I keep logging my activities right off my phone, and then it shows up in my computer, and then it shows up into my database, and I can do all kinds of cool stuff with that data because of the APIs that are provided there that make stuff possible. Helps if I click in the right window. Just some fun stats if you need some more proof why this stuff's important. So we surveyed, not we, an organization whose business is about the API marketplace, like their literal business is helping developers build and sell their APIs. So they surveyed those like 10,000 developers. So 74% of them said, yeah, leveraging existing code is a huge thing that we do. Automating events, increasing productivity. Like this is all about being lazy. Why spend time doing something when the thing's already been done and the library's just there? I just pull down the development kit, I read the API docs, I go, oh, yeah, that's what I want. Let's go make that happen. And I'm just using someone else's stuff instead of having to do it myself. Creating better software, so if you build something once correctly at the API level, everyone can come in and build their own stuff on top of that. And there's like a common core of features. The software and the solutions are better because they're more consistent. Yeah, you might have had a bug, but at least it's the same bug everywhere, and you fix it, it gets fixed everywhere too. And it's less code that someone's writing themselves. And anytime someone writes code, that brings in the possibility that there's going to be a bug. This is a huge one. So businesses like to make money, and businesses like to not share their money with other companies, but if they find a way to work with another company that helps them and maybe also helps the other company, they're going to do that. So we have these partners, and Oracle has tons of partners, and pretty much any company you can think of has an entire organization that does nothing but bringing in partners. APIs allow us to share our data, share our processes with each other, whether that's selling information that we collect or making it real easy to track things, from one person's online e-tail to another person's shipping or whatever. If you got the APIs just sitting there, of course, those integrations can happen much, much faster. And it's a worldwide phenomenon too. So it's not just an American thing. I don't know if everyone here today is in the US or in North America, but this is a worldwide thing. So APIs, REST APIs, they're being used everywhere. So this is not some esoteric thing that if you spend time learning, it's not going to be useful if you move into a different industry or even move into a different part of the world. It's truly global in all sense of the word. So what I'm going to go over today is, just what is an API? What's an application programming interface? And then spend a lot of time on, hey, what makes an API RESTful? So REST APIs are a very specific kind of API. It's not a specific protocol like TCP or like what ATMs would use. It's an architectural style. So it's a list of attributes that if your APIs follow, it's going to say, oh, that's a RESTy or a RESTful, or that's a REST API. And when developers see these and they see that word, they immediately know what that means, and they can make certain assumptions. And if you meet all those assumptions, then your APIs are friendly, which means they're very easy to use. They do what they're supposed to do, and people are going to build really super awesome things with it. So I'm going to stress a bunch of that today, because if you decide to go into the career space of being a developer and you start building APIs, the saddest thing ever would be for you to build an API that you love, that no one else likes, and no one uses it. So no one's benefiting from your work. No one's getting to share and use your data. No one's using your stuff. And I want to help you avoid that. And the best way to do that is to make your APIs friendly. I do work for Oracle. I'm not here to talk about Oracle really at all. But apart from being interested in REST APIs, I'm also a data nerd, data freak. Like, I log everything that I do. I drink beers, and I log into an app called Untapped. I go do a obstacle course race. I log that in Strava. I even have access to like my water meter data for my water utility, and I track all of that, and it all goes into a database. I love playing with data. I like looking at trends. I like playing with SQL. And so my examples today are going to be more based on examples of using REST APIs or APIs to work with data. But don't think that APIs are limited to just working with data or in a database. It's literally any piece of infrastructure, any sort of object, any sort of process in the world is going to be generally having a REST API there to interact with. But my examples are all going to be on the SQL or the data side. And then I'll have a couple of resources at the end to share. So, just what is an application programming interface? If we were in a class today and you had the test, you might be a little worried that you couldn't answer that. But hopefully at the end of this, you're going to be feeling more like Mr. Smart Dog here. You're maybe not an expert, but you're definitely feeling more confident. If this topic comes up in class or in a job interview or in school, in a work project, you at least have a kind of common ground to go from. And if you do need to go research it further, you know what, at least to Google or keyword search. This is kind of a dumb metaphor, but it worked on me, so I'm going to share it. In an API, in a REST API specifically, you're going to make a request. When I say you, it could be literally me as a person. More likely, it's going to be a program that you've written, or it could be an automation task or process that's sitting somewhere that's getting triggered. And that person or that thing or that program is going to look at a menu of things that it can call, and it's going to decide to call something. And on the other side of this transaction, we have the server. In this case, it's the restaurant server or the waitress or the waiter. Their job is to sit there and to take that request and then deliver back whatever that API request represents. So hopefully this guy gets his sandwich or taco or whatever. But in an API situation, it could be, hey, give me a list of restaurants that are within geolocation 2.5 miles of where my phone is reporting me right now. So that's a real world thing. You've got mobile apps. You pull up your device and you pull up your mapping thing, and it goes, hey, show me restaurants near me. For it to get that data, it's literally asking some API for something. And on that request, it's sharing information. Like, here are my GPS coordinates. Gosh, in today's world, it's probably telling them how old I am and where I've been the last 3 days. Gosh knows whatever's being shared. But this guy's like saying, hey, my request is this is what I want, and hold this and give me extra that. And, and the server is going to take the request. It's going to process the request. And it's either going to come back with a ticket like, hey, you're number 57. Take this ticket, and we call number 57. You can go get your order. Or she's going to come back with, hey, here's your taco or your sandwich or whatever. That's generally how the REST API process should work. I make a request and I get a response. There's two types of these requests and responses. There's synchronous and there's asynchronous. Synchronous would be, I'm on everyone's favorite ticket broker for concerts. I won't say their name. And I'm buying a ticket, we'll say, to the most popular act on earth. I want to go see Taylor. Somehow I got the magic lottery, and I'm going to go buy tickets for my wife and daughter so they'll love me forever. And I put in that request, and I immediately get back a response. Yes, your tickets were purchased. Here's the link to go download the tickets to go into your mobile app. That's a synchronous request where you make a request and you're sitting there waiting for the response to come back, and then we're done. An async request would be more like you make a request, you get an immediate response back, but it's more like the restaurant example where you get the ticket number 57. Like, okay, here's your receipt for the thing you asked for, your number 57. And in the real world, I wait for them to call 57. But in the digital world, 57 is really probably a link that I can follow or watch. And then when that request is finished or done, it's going to say, oh, okay, here's that thing you asked. And everything that I need to go get what I want from my original request is on that receipt 57 that I was given. So that's async, sync and async. As an API developer, you want your APIs to be fast, super fast. And if you don't build fast APIs, then you invite the user or the consumer of the product to do dumb things. So for example, my wife loves it when we go on walks and we go up to the crosswalk and she hits the button to request the crosswalk light. And then 3 seconds later, I get impatient and I walk up and hit that button 10 more times. If you've ever been on a website and you're buying something and you get that message back and it's like, oh, hey, we're making the purchase request right now. Whatever you do, don't hit refresh on your page or you're going to pay us twice. That's not a very user-friendly interface. And there are REST API implementations you could do to avoid that, to avoid the user from having a bad experience because they get their response right away, and also to avoid accidents where they accidentally give you too much money or they accidentally have too much money, taken. No one likes that. So that's all part of this friendly API world that we all want to live in. Client sends request, server takes request, responds. Client server. There are lots of different types of APIs. I'm here to talk about the REST APIs, but I should give you just a general overview of all of the many different types of APIs. But one of the reasons I'm talking about REST APIs is because they're by far the most used or most ubiquitous. So REST is an acronym. If there were ever a test on REST APIs, I guarantee you this is going to be one of the lazy multiple choice questions. Representational state transfer. RE is the representational, and then state, and then transfer, which basically means everything that you need to know about what this person wants is described in their request. So there is no before, there is no after. Everything is atomic. Every single thing you do is a standalone request. That's basically the nut and bolts of what Ray Fielding designed in the CERN lab in the 90s. So I've got a great question on screen. I don't know what your name is. I'm going to say JShaw12. Is the server an API? Great question. The server, let's answer that two ways. In the restaurant example with the real world, the server is the waiter, right? And then the waiter is going to bring to you the menu. That menu are the APIs, like the things you can ask for, like the things you can have done. And the server is the one that's hosting the menu, and the server is the one that's taking the requests and doing the work. So servers in the real world would be like a cloud instance, maybe a compute node, maybe it's an Apache or a Tomcat web server, maybe it's a Node.js server with some JavaScript code in it, and coded into these server machines are some APIs. And the APIs, you can't use an API if you don't tell people what the APIs are. So there's generally going to be like an API documentation set or literally an API web interface that describes the APIs. So Swagger is a tool that you can use as a developer to share your APIs with other developers. And there's something called Open API, which is a specification that allows you to describe APIs. So with either the Swagger tooling or the API spec running on a machine somewhere, it's making those APIs available. And the APIs are almost always coded in Java, C, C++, JavaScript, maybe Python. So Bob's asking, the waiter is the API between the user and the chef. Yeah, you could look at it that way. Yeah. The APIs are almost always somewhat the middle person in the transaction, right? But the APIs are the literal interface that the chef or the kitchen or the restaurant is making available to the person at the table to say, hey, here's how you interact with us. It's literally a way for two things to interact with each other. Although generally the server's not reaching out to the client, it's always the client that's reaching out to the server, especially for REST. For REST, it's always the client reaches out to the server. Webhooks allow real-time interactions, and this allows the server to reach out to the client. So let's say something important is happening and you want to let someone know about it. you can't wait for them to ask, hey, did anything happen? I want to be able to tell that person right away. I know they exist. I need to tell them that their Taylor Swift tickets are available. So a webhook would allow the server to reach back down to the client. GraphQL, this is an API style that Facebook put together and then open sourced a while back. It's very much like a REST API. So with the REST API, you're going to make a request for something and you're going to get something back. The things, I'm going to get into this in a second. The things have a set of attributes and they're almost always stored or represented with JSON or JavaScript object notation. So the curly brackets and it's a value pair. So I've got an ID, I've got a name, I've got an address, I got a salary, and I've got a sex or gender or whatever, and date of birth and all of that good stuff in my profile pic, right? So if someone asks a REST API for Jeff, what comes back are all of those attributes. REST APIs are great. They do have a couple of downsides, like the requests, the payload, which is the payload is like the contents of the response. So like those JSON objects coming back or the arrays of JSON objects coming back. Maybe I don't want just my employee record, but I want every single employee record in the company to come back. If we've got 30 attributes for an employee, but I only care about their name and their birth date, that's inefficient. So what GraphQL did is they solved this. GraphQL says, hey, we can turn this into sort of like a query. I want just the name and the birth date for the employees. So on the request, it looks kind of like a REST request, but instead of asking for employees, they're saying, hey, give me employees, and under employees, I want the name and birth date, and it gives me just that. So less information means there's less to transfer over the network, which means faster response time, which means faster page loads, which is probably why Facebook invented it, because they're all about faster page loads or people leave. SOAP is pre-REST, and instead of JSON, it's all XML. It's important to understand a little bit because there are systems that were built a long time ago that are still in use today. I don't know of many new projects that are standing up on this simple object access protocol or XML, but there's tons of projects that are actively being used. And so you might get a job as a developer where you're maintaining or fixing bugs on it. And then after that, there's a huge drop off on the different one. The new cool kid is WebSockets, which allows you to do two-way transmission or two-way communication, where it's not a client making a request to a server, or it's a client making a request to a server, and then the server can like ping back the client. It's literal like a constant open web literal socket or a connection where the two people can, it's like a telephone conversation where we can just go crazy back and forth each other all we want. All of these API styles have pros and cons. Right now in the world, it's like almost all REST APIs or some derivations of that. Like, so for example, if you look at the APIs out there now, I think REST is something like 75 to 80% of the implementation. And then GraphQL is like 20, 25%. All right, so REST APIs do not work if we don't have HTTP or Hypertext Transfer Protocol. And most of us know those letters because they are what we start typing when we go into our browser and ask for a website. So literally when you type into Chrome or Safari or whatever, HTTP, CNN.com or ESPN.go, whatever, wherever you're going to go, Spotify is where I usually go in the morning, or Outlook to check my webmail, you are literally making a GET request to get something from a server somewhere. And on the end of that URL is an API. So there's a literal server hosting something, and I'm asking to get something off of it. So REST APIs, it's all about, we want to model an entity or a thing. Like, for example, my exercise activities that I log with Strava, let's call it an activity. If I'm in my app and I want to run a report of, hey, what did I do yesterday? I would make a GET for a request of my activities. And I could say, just give me everything. Or I could say, get me a specific thing. Or I could even say, hey, just get me the things that happened yesterday. But that's a get request. And I'll explain why I have this in green in a second and why some of the other things I have in red. But literally, you're just asking for one thing or a collection of things. Nothing ever changes on the back end. The server is never doing any work except giving you the things that you asked for. Post. This one's more fun. So I, as on the client side, I'm going to collect some data, some information, and I'm going to send it to an API. In the verb, I'm going to use this post. And then the server, the backend, the API, whatever, the kitchen, is going to do something with that data that I gave them. And then they're going to do something with it, and then they're going to give a response back. Now, this one is a bit more nebulous or hard to describe because literally what the backend does with the thing that you've given them could literally be anything. But normally what it is I am posting something to be added. So for example, probably when I'm on Instagram and I click create post and it takes a picture off my camera feed or off the storage, it's probably doing a post of the MP4 or the PNG or JPEG or whatever file, and it's sending it to the Instagram server. And then what comes back, if we're just adding that thing or that picture, so the thing that we're sending is probably the picture, and there's all kinds of bunch of metadata attached to the picture, so they know the size of the picture and the resolution, and I might have added some comments to the post or whatever. All of that goes up to Instagram, and then what comes back is probably a notification that says, hey, your request was successful. We added the thing that you asked for, and probably here's a link that you can follow, or the app just automatically follows to continue working on your post, your literal Instagram post. This one's in red. Again, I'll explain why it's in red in a second. So by the way, these are the verbs. So when I was talking about we're going to have a thing that we model, and then we have verbs that work against that thing. So in an API request in the REST world, we have the universal resource locator, or the URL, or we have the universal resource, is it indicator? There's a URI, but basically it's generally the hyperlink or the link that you're following. And on the end of that, there's usually the name of something, but it's going to be something called like pictures or activities or emails or something. The end of the thing isn't going to be create email or delete email or send email. It's going to be just email. And the way that we communicate with that API is we say, hey, that emails thing that you have, let me get one. Let me post one. Let me put one. Let me delete one. So one of the mistakes you can make when you're getting started in creating REST APIs is you put these verbs in the name of the thing, and that'll confuse API developers because they're saying they're used to using the action or the verb that they want to make in the request, not in the name of the thing they're dealing with. Anyway, put allows me to either create or replace a thing on the server. So let's say we have an employee system and everyone has an employee ID. Back in the old days, we'd always use social security numbers to do that. And we realized that was a really bad idea. Don't do that. So we generally have these system generated numbers. We'll just say numbers from 1 to 10,000, So if I'm going to hire a new employee, I'm going to put that new employee in the employee system. I'm going to do a put request that says, hey, put employee 105 into the system. Or more commonly, my job has changed. I have a new salary. I have a new job title. I'll do a put to employee 105 with the new description of employee 105. So here's the thing that you already have. Here's a new version of it. So let me do a replace. But it can also be used to do a create, or sometimes it's known as an upsert, where it's either, hey, add the thing if it's not there, but if it is there, replace it. REST like I said, it's an architectural style, and it's not necessarily a programming language or like a. So anyway, when we have these things that are described, you'll have parties that get into fights, and it's almost like a religious war sometimes. Like, I grew up in a Southern Baptist world, and we talk about the other Baptists. There are actually developers out there, they'll argue, well, put should be used to add stuff and post should be used to create stuff, and vice versa. So just beware, you read the documentation, make sure you understand what the APIs are before you start just using them, because sometimes they might be a little bit different. It's when those APIs are a little bit different that you run the risk of them not being friendly, and it makes it harder for the developers to use. Delete, this one's pretty simple. We're going to delete something, right? You're going to make it go away. So in your APIs, you don't want to have an endpoint called delete employee, because then you could theoretically do a GET request on delete employee. What's that mean? Am I making a request for employees that got fired? That's weird, right? The name of the endpoint should just be employee, and that means they're going to get one, post one, put one, or delete one. These are the 4 biggies in REST APIs and in HTTP, right? These are the 4 verbs that you'll see the most. We also have a head, which basically is the same thing as a GET, but instead of getting the body or the actual object, I'm going to get just the metadata or the descriptions about the object. So I could get the link for me, or I could get some attribute of me, but it wouldn't actually have my object if they were going to get my record. Head is much faster. And if you need just a little bit of information about the thing instead of the thing itself, you'll see head used. Patch. Patch does a partial update. So instead of completely replacing the entire thing, it allows me to change just one thing about the thing. Hate to keep using this word. But if I literally wanted to just change my salary, I could patch request my record with just the new salary in it. Whereas if I did a put, I would have to have the entire object there with the new things in the request. Whereas patch allows me to send one thing and change one thing. Options. This allows me to see as a developer what verbs are available. So when you see APIs, like I've created an API called activities, I could give you a get, post, head, put, and delete verb to use, but I could maybe just give you get. So there's these things called open APIs where people share their data, and they're not going to make it so you can delete their data, right? So maybe the only thing they give you is the get request. So if you want to know what's available, you can make an options request, and then the server comes back with the verbs that you're allowed to use. So there are more than this, but these are the biggies. Now let's talk about the greens and the reds. And this is a little bit of math, and I apologize. Idempotent basically means I can repeat the operation over and over and over again, and I'm not going to end up with multiple things on the server. So I can make the delete request as many times as I want. The end result's always the same. I can make a request to get something over and over and over again. The end result is always going to be the same. I can do a put request over and over and over again, and the thing's always going to be the same because I'm either creating or replacing the thing. But the post, if I make the request over and over and over again, I could have 5 of those things. So when you're in your app and you're trying to buy something and it's sitting there going, oh, hey, don't hit the refresh button or you're going to buy this thing twice, there's a good chance that that is not asynchronous and it's implemented via post. So if you want to avoid that stuff when you're building apps, then you can take advantage of knowing this. And then they have a very fancy word, but not a very fancy word to describe the opposite, non-idempotent. And this just basically means it's not guaranteed that there won't be additional changes or additional things created on the back end. So patch, you would think is idempotent, but theoretically or commonly, it could also be non-idempotent. So I'm taking longer to go through these than I thought it would, so I need to speed up a little bit. Okay, so this is HTTP in the verbs. But having an HTTP interface to something doesn't make the API restful in itself. So building REST APIs doesn't just mean we're using HTTP to do the work. By the way, the reason REST APIs, I think, are so ubiquitous and everywhere, they're the lowest common denominator. Every programming language in the world, every platform, every framework is set up to work with HTTP. Even Fortran programmers can use HTTP today. So you don't have to download special software. You don't have to download special drivers or kit from the vendors. Like Python, JavaScript, they have this library called requests where they literally just say, hey, go do the requests. And then they've even got code in there that makes it really easy to deal with the JSON objects that come back. Eclectic, I appreciate that. Thank you. That was very nice of you to say. And Bishal is asking, is an API like making a function to do something that we actually need in an app? Yeah, literally it could be, Bishal. So if your app needs to, pull something from somewhere, like get some information or to share some information with something somewhere else. Remember, APIs are for allowing two things to communicate with each other. So if your app needs to communicate with something somewhere else, like if your app needs to communicate with iOS and the device, well, the Apple developers have given you APIs that you can use to interact with core features on the phone. So you're going to be able to make API calls to interact. Like you could go see what the battery is left on your phone. So you know in your app to disable 4K resolution on pictures, for example. I'm making these examples up as we go, so if they don't make total sense, I apologize. All right, so what makes an API RESTful? One of the things is uniform ways of interacting with the server, and a lot of that is what I was just going with. Hey, you've got a thing. We're going to model that thing. We're going to do the verbs, like the get, put, post, delete across them. Oh, self-descriptive messages. So remember, if we scroll back like 15 minutes ago into my rant ramble here, every single request we make has to be possible with the information we have in that request, right? So the transaction is the one thing. There's not like start transaction, do 27 things, oh, roll back 3, keep going. No, every 27 one of those things is a single request. So it's very important that when you get a message back from the server, that the message gives you everything you need to go do the next thing you want to do. So for example, Taylor Swift tickets again on that popular ticket exchange site. Hey, I got the ticket. It tells me, hey, we got your tickets. And then guess what? It doesn't show me or tell me where the tickets are, how to get them. It's like, oh crap, like where's the ticket that I just paid $10,000 for? And generally the way we communicate that kind of information is with the literal link. So link driven, or the internet would not work without links. That's part of this. Hypermedia is the engine of the application state. I guarantee if you ever have an API test again, this will be question number 2. What is hypermedia as the engine of application state? Or what is OS? No one knows how to pronounce this. And no one even knows what it means. When they see this word, it means links. Use links everywhere, because without the links, you can't do anything. Links tell you where to go next. Links tell you what things are related to the thing that you were given. Links give you the information you need to go do the next thing in your things that you want your app to do. So for example, I ask for a list of items on the menu, and maybe just the name of the things. Hey, tell me more about the quarter pounder with cheese that you got. Well, hopefully on that thing, there is a link that if I click on, it goes and gets me the full calorie nutritional breakdown of the quarter pounder with cheese. And then when I see that, I go, oh crap, I'll have the salad. And then I go look at the salad and it's like, oh, it's got avocado and ranch dressing. It's like, oh crap, I guess I'm just drinking water today, right? So without the links to go get the extra information on that list of things that were given, the menu is useless. So don't create APIs that don't include lots of links in your responses, because you're making it really hard for the app developer to know what to do next or how to go get more information to interact with these things that you're trying to share with them. So it's all about being friendly. So it's client-server separation. You could have 15 clients all working with one server. No one knows anything about the other. The other thing that this is important for is I could have one set of APIs, and I could have 3 application development teams all build the exact same client in different interfaces and programming languages. So I could have one set of APIs that my Android developers go build a mobile app for, that my iOS developers go build a mobile app for, and that my website builds an app that builds a website for. And they all use the same APIs, but it's 3 completely different clients. And it's super kick-ass awesome because I've done that work on the back end once, and all of the clients get to be built independently of each other, and they're all using the same code. So again, I'm sharing all the bugs, then also I can release features and they all go to the same places. Stateless, I've talked about this a few times, but we don't know what happened before and we don't know what happens next. Really, the only way that would be communicated is with a link maybe to go, to go see something else or to go do something else. But in the request itself is literally every single piece of information the server needs to make your request happen. There can't be any, oh, hey, remember that thing we did just right ago? Take that information, help me do the next thing. No, that's not there. So that thing you needed them to know, you got to send that in the request. Cacheable. Caches are the worst thing and the best thing ever. We put stuff into memory. Memory's faster than, getting something off disk because disks are slow. So we put caches everywhere. You need caches on the phone. You need caches on the web servers. You need caches in the domain name systems all over the world. You need caches on the servers where the APIs are. So basically for REST APIs, you just have to be able to have a caching mechanism for the data that you're working with. We talked enough about that. So let's go build some APIs. My kids love Minecraft, so I had to throw in a Minecraft gift for them. Come on, next slide. Next slide. Okay, so again, remember, I'm a data person. I love SQL. So if you've never heard of structural query language or SQL, if you've seen a select star from with an order by or a group by clause, that's SQL. It's very descriptive. I'm telling the server what I want. I'm describing what I want, and I'm not telling the server how to get it. So I'm not writing the bubble sort algorithm to sort the salaries. I'm just saying, hey, I want the activities that I did, and I want you to sort it by the amount of time it took descending. So these are the longest operations that I've logged in my Strava app. So I spent 8 hours to power wash my own house one day because I was too stubborn to hire someone to do it for me. And that's in my Strava app. So these are rows that are coming out of a table from a database, and I'm using a SQL client. And if anyone ever asks what's the best database in the world, you just tell them Jeff said Oracle, and they'll believe you. By the way, we own MySQL too, and it's also really awesome. But I don't want to go work with the database. I want to use these cool REST APIs you're telling me about. I don't even want to learn SQL. Screw SQL. I want to do this get, post, put, delete stuff because that's easy. And you told me REST APIs are the lowest common denominator, Jeff. Let's do that. So what's very common is your data can be made available via REST APIs. So I don't have to know the database. I don't have to know SQL. I just have to have the APIs. Here's an example of an API doc, like a Swagger toolset might give me. This is a very generic one, a very boring one. There's literally just one API here. There's a thing called activities, and the verb that's available is get. And somewhere on this page would be a button called try it now. And then when I click that, literally in the web page, I could see the request being made and I can see the data coming back. So this is an array of JSON objects. And if you want to make people mad, call it JSON. I usually poll the audience. I'm like, hey, do you guys call it JSON or JSON? And whatever they say, I just do the opposite just to mess with them. If you say one, everyone knows what you mean. But if it comes up on a test, pronounce it like the serial killer. JSON. JavaScript object notation. It's super popular way to transmit data. This is an array, which just means it's a collection of things. So ask for all of my activities. See that little slash on the end? Think of that as like the index. I want the listing of all of the activities. So what I got back was a listing of all the activities. Remember I said links were important, and if you don't use links, you're dumb? Well, I built a bad API here because here I am giving you a list of things with no links. So this is not a friendly API. A friendly API would look like this. Here's the list of things, brief descriptions, and if you want more information about the things, here's the link that you follow to go get the rest of the information for a specific activity. And here's me browsing an API with a bunch of links and clicking on one of those things and getting just the thing, just to show you that it's real. And if you look at the event that we're also hosting, it says something like REST APIs and Oracle database. We'll show you how to put data in a database, our database. You can use one for free, and then how to build an API over top of that. And that's what I've done. Here's my thing. Use your own data because it's much more interesting to you, and no one knows your data better than you. So yeah, you could go play with an open API data set. Like New York City has like, it's a popular one. It's like all of their e-bike rentals. You can go download the activity and see how many people grabbed e-bikes out of Central Park and where they rode them to. It's kind of cool. But what's more interesting is like the stuff that I'm doing. So like my iTunes library, back when people used iTunes, you could download that and see what song you played the most. Spotify, like I don't have to wait for the Spotify year in the review. I just ask Spotify to give me my personal data, and I can ask literally any question I want about like my music playlists. Like I want to know, I don't want to know my top 10 songs. What were my 10 worst songs? What were the 10 songs I listened to and immediately turned them off after 3 seconds? You know, so I could answer those questions with SQL, but I could also answer these questions with REST APIs. Let's post an activity. Let's literally add a thing. So this is much more interesting than gets. Curl is a command line program that'll run on Windows, Macs, Linux, pretty much anywhere. It's not very user-friendly, but it's the lowest common denominator for making REST API requests. So you'll often see in the examples online or in the docs, hey, here's how to use curl. Now, if you want to get ahead in class, go download a free tool like Insomnia, or in VS Code, download an extension for REST APIs, or maybe go use Postman. These are GUIs that allow you to make REST requests. But if you want to be as good as possible on an interview or something, or a test, basically at least know how to read curl. So here in curl, I'm saying, hey, I'm going to make a post request to this thing called activities. Here are the headers. By the way, these headers, if I made a head request on activities, what would come back are just the headers. And then here where it says -D, and then I've got the open and closed brackets for this JSON object, that's the body of the request. So I'm basically saying, hey, I want to log an activity whose name is 100 days of push-ups, day 4, activity type cardio, description, ow, strong arm, elapsed time, 2100 seconds, distance 0, and there's the date and time that it happened. So I'm going to post this request to my activities resource. So I'm the client saying, hey, let's go log this. The backend's going to see that request, the Strava website. It actually comes directly off my watch. I never do this. The watch does it for me. But this is what the watch is doing. Here's the activity that it recorded. And then here's the response back from whoever the API server is. In this case, it's my database, but it could be strava.com. It's coming back and saying, hey, status code 201. I don't have time to get into status codes, but status codes tell you what type of thing happened when the server processed your request. 201 always means, hey, we added something for you, and here's a link to go see the thing that we added. And in my case, I built it so it automatically took me to the thing that I added. So I could have just came back a link that said, hey, 201, here's the activity. But in my case, I use something called a forward request that tells the app, hey, just automatically go to the link that I'm going to give you. So here's the record on the back end. So it made a GET request for free off the response of the post request to add the thing to actually bring me back the thing to see. So this is how it's stored on the back end. And I can make this GET request as many times as I want, and nothing ever changes. But if I make this post request 10 times, I could end up with 10 different items on the back end. Probably wouldn't, because it would probably fail because it's like, hey, this ID already exists. So I get like a bad status back, like a 500. If you're ever using a website, something goes wrong, and you get a 500 status message, and it says something like on the screen, is like, oh, something broke on the back end. Sorry, check the logs. That's a really lazy developer that did not build in error checking, and something on the back end failed, and they don't know what to do with it. Something hiccuped on the back end, and you're screwed. Nice developers will build in multiple layers of checks anticipate problems, and when those problems happen, give you some sort of route to try again, or to come back later when things are working. You can't anticipate everything, so sometimes you will get a 500 message back, but you can, as a developer, anticipate the stuff and lessen the chances for those 500 messages to come back to say, oh, sorry, we we made a mistake. There's nothing we can do to help. My favorite movie, I'm old, sorry, older than you probably, but my favorite movie is Roadhouse. It's a bad movie, but it's a good bad movie, if you know what I mean. And if you watch the original version, I think it's on Amazon Prime if you're a Prime subscriber, but it's worth the $3 to rent. I guarantee you, you're going to like it. And if you don't, you can blame me. Ask me, I'll give you $3. You can go watch something else. But his number one rule is this bouncer is to be nice. He's like, just be nice. And when it's time not to be nice, I'll tell you. But I'm going to say always be nice when you're building your APIs. Because if you make nice APIs, lots of people will come. And lots of people, I guarantee you this, it always happens. You build a cool API, people are going to build the most amazing things to use those APIs that you never dreamed of. Like you might be like, hey, I'm going to build this API so people can do this. That's just the beginning. People are going to go do things on top of that and stretch that and do all kinds of weird stuff. It might freak you out that people are doing stuff you didn't mean for them to do. But when you see what they've done with it, you're going to be like, oh, wow, that's cool. And that only happens if your APIs are nice. And the way to make APIs nice, you make them resty, you make them predictable, you give them all the links, you code in checks so that you don't get bad error message back they can't do anything about. So yeah, just be nice. I watched the new Roadhouse. It wasn't bad. It was a completely different kind of movie, but I like Jake Gyllenhaal. He did a good job with it. And I'm a Family Guy fan too. So there's a 3-minute YouTube clip that you can watch of just all of it. It's profane as heck, but if you've seen the Roadhouse movie, and then go watch the Family Guy clip, you'll laugh. I've only shown like making these requests and seeing the naked JSON come back. That's useless. What we're really talking about is building applications on top of these APIs. So the apps on my phone, the things you see on the screen, any programming language or framework you want can do this, can use the APIs. That's what's awesome. So if you got a team of developers that just kick butt in TypeScript and JavaScript, you can set up the Node.js server and they can go to town on the APIs. But if you have another group of developers in California that just prefer Spring Boot or Java XYZ, they can go do that, but they're all still using the same API. So here I've got just a web page that's putting up data on the screen, and all this data is being sourced by probably at least 1, 2, 3 different APIs. So there's probably 3 requests being made on the page to get this data, to get this data, and to get this data. What comes back is the JSON, and then it's the JavaScript framework and the code that's running in the browser that takes that data and paints the pretty pictures over it. And obviously links would show up as literally links. So maybe if I click on that thing, it clicks the link to take me to that group of data. I was talking about my activities. So here's another example of what this looks like. So this is my actual Strava data. It's up current as of 2021. I need to go do this again. But I've built all of these different JavaScript, HTML, CSS powered charts. And all of the data is being sourced from my Oracle database. So my web app is making GET requests against my Strava data, and it's being presented in all these different ways. Now, here's the trick. If you're in a web app, and some desktop apps too, if you open up this thing called Developer Tools, you can literally see the internet traffic that's happening behind the scenes. So when I open this and I hit refresh on the page, there's a network tab. If you click on the network tab, here's the API request. Here's the verb, the GET. The response was the 200. There might be other, say here are the headers. So this is the information. Here's the literal request that was made. And then on the response tab, you can see the data that came back. In this case, it's that array of JSON objects. So here it's literally all of the data that's being used to create this pie chart. I told the organizers I wasn't going to take the whole hour. What a liar I am. Although I took 55 minutes, so maybe I can get away with it. If you want to meet me, I'm somewhere in the Discord app. If you can't find me there, if you Google Jeff Smith Oracle, I'm all over the place. I'm on Twitter. I'm on LinkedIn. Feel free to reach out. If you want to know more about REST APIs from the Oracle database perspective, just go to oracle.com/rest. This is being recorded. So if you want to send this to your mom and dad to watch later so they know what you do for a living, don't do that. They won't understand it. My mom and dad don't. But if you want to take notes later or refer to this later, the organizers will make this available for replay. If you want to take the lab that we have, you're going to get some data. You're going to put it into a database. You're going to write some SQL against it, and you're going to click a button and get REST APIs that pop out, and then you can start playing with the REST APIs. And I'll be here on the Discord server to help you. And then if you want to learn more about this stuff, go to these links. So last chance for you to ask a question. Otherwise, I'm going to say thanks for the time. This is my first, I think technically my first real streaming kind of thing that I've done. My daughter would be proud of me because she watches the streamers play Fortnite all the time. I can be one of the cool kids now. But good luck in the rest of the event today. Have fun. That's the main thing. And I'll talk to y'all later, I guess. Ciao.
Awesome. Well, thank you so much, Jeff. I will go ahead and end out our stream. I will post all the links that Jeff put up here over in Discord as well. So if y'all need to find them over there, and we will see you all in the next stream. Bye, everybody.